Have you ever looked up at the night sky, filled with countless stars and distant worlds, and wondered? We often ask if there is life out there, perhaps on a planet orbiting a faraway sun. We imagine aliens, microbes, or strange plants. But what if we are asking the wrong question? What if the planet itself is the life form? It sounds like something from a science fiction story, a world-sized creature floating through the vast, empty darkness of space. This is a truly profound idea, one that challenges our very definition of what it means to be alive. It asks us to see our own world not as a rock with life on it, but as a single, unified living entity. This idea is not just a fantasy. It is a serious scientific proposal with a beautiful name, the Gaia hypothesis. The story of this revolutionary idea begins not in a biology lab, but with a scientist working for NASA. His name was James Lovelock, and in the 1960s he was tasked with a fascinating problem: how to detect life on other planets, particularly Mars. We could send a lander to scoop up soil and look for microbes, but this approach seemed limited. Lovelock compared the atmosphere of Mars and Venus with that of Earth. He noticed something striking. Mars and Venus had atmospheres that were in a state of chemical equilibrium. This means they were stable, predictable, and quite frankly, dead. Earth, however, was completely different. Our atmosphere is in a wild state of disequilibrium. To understand this idea better, let's think about our own bodies. Think of it as Gaia's lungs. Just like our lungs take in oxygen and release carbon dioxide, the Earth's living systems are locked in a planetary-scale respiratory cycle. If the atmosphere acts as the planet's lungs, then the vast oceans are its heart and circulatory system. It functions much like our own bloodstream, delivering vital substances to where they're needed and carrying away waste products. Perhaps the most compelling piece of evidence for the Gaia hypothesis is the puzzle of Earth's long-term temperature. With such a weak sun, early Earth should have been a frozen ball of ice. Yet, the geological evidence is clear. For almost its entire history, Earth has had liquid oceans and has supported life. The Gaia hypothesis suggests that as the sun grew hotter, life itself evolved ways to actively cool the planet, keeping the surface temperature within a habitable range. When James Lovelock and Lynn Margulis first introduced their hypothesis, the scientific community was deeply divided. To demonstrate this, Lovelock created a simple computer model called Daisy World. Scientists began to look for real-world evidence of Gaian mechanisms. One compelling example comes from marine phytoplankton. When released into the atmosphere, DMS particles help seed cloud formation, which reflects sunlight back into space and helps cool the planet. The Gaia hypothesis doesn't just change how we see our own world, it completely revolutionizes how we search for life elsewhere in the cosmos. We can study the light that passes through their atmospheres. This light carries the chemical fingerprint of the planet's air. Scientists call these potential signs of advanced alien technology technosignatures. One theoretical idea is that they might build enormous structures around their star to capture its energy, a concept known as a Dyson sphere. This Gaian view of life also offers a new perspective on the Fermi paradox. Our galaxy is vast and ancient, containing billions of stars older than our sun. So, as Fermi famously asked, where is everybody? The silence from the cosmos is deafening. Perhaps living planets are common, but they are also incredibly fragile. Perhaps the universe is filled with the fossilized remains of planets that were briefly alive but could not achieve a stable Gaian state. If Earth is a self-regulating system, then humanity, with its powerful technology and global reach, has become a new and potent force acting upon it. We are now in the Anthropocene, the age of humans, where our collective actions are the primary driver of planetary change. From one perspective, our industrial civilization looks like a planetary fever. However, this is not the only possible future. We do not have to be a fever. We can choose to become a different kind of force, a stabilizing one. The influence of the Gaia hypothesis extends far beyond laboratories and scientific journals. It provides a powerful, science-based narrative that resonates with ancient, holistic views of Earth. If the Earth is a living system, then it has intrinsic value, and its health is our health. We are not just rational animals on a lump of rock. We are the conscious part of a living planet, the part that can look back and understand the whole. This gives our existence new and profound meaning. We began this journey with a simple yet profound question. Could a planet be alive? It asks us to see Earth not as a passive rock decorated with life, but as a single, magnificent, self-regulating system. We are children of Gaia. So the next time you walk through a forest, swim in the ocean, or simply feel the sun on your face, take a moment. Consider that you might be participating in something much larger than yourself. It leaves us with the most beautiful thought of all. We live on a remarkable world. A world that might just be alive.